We've combined elements of a tree into a number, but what about something even more complicated? This time, we'll write a function that traverses a tree and combines all the odd numbers into a list. Before we get to that, however, we'll write a simpler version of the function that just flattens the tree into a list of numbers. To do so, we'll take advantage of the append function, which consumes a number of lists and joins them all together. We'll begin with flatten tree, consumes a binary tree of numbers, and produces a list of numbers. Consumes a binary tree of numbers and produces all of the numbers into a list taken from the tree. We'll simplify that. All right, we define our header, flatten tree, ABT, leave the body stubbed out, write some check expecs, as we always do. Flatten tree on a false tree produces the empty list. No problem. Flatten tree on a simple one element tree produces just a list of that one element. Smooth sailing so far. And our last check expect, we can flatten our big old tree from before, the number tree, and that produces the numbers in the order shown here. I don't really care how I produce the number, like what order the numbers end up in, but this would be the natural ordering that I would produce, so we'll use that. And now we go and grab our list handling template, our tree handling template once again. Scroll up the original problem and paste it in. All right, replace the names. BT fun becomes flatten tree. ABT replaces BT everywhere in the template. Get all that code for free. Now, what are we doing here? In the empty case, the false case, the base case, we say that we return a empty list. So that's pretty straightforward. And now we need to think about what we do for each of these. We have a node value, and that will be one of the numbers from the tree. And we'll have the flattened version of the left tree and the flattened version of the right tree. Now both of those are going to produce lists. So we need some way of combining the left flattened tree and the right flattened tree. Remember before I said there was that append function which consumes lists and produces lists. We can use it down here. Append the list 1, 2, 3 with the list 4, 5, 6 produces the list 1, 2, 3, 4, 5, 6. Now we can append together the result of flattened trees, but node value is just a single number. We need it to be a list. Easy solution, we'll just wrap it in a list. So we'll take this and just say list of the node value. Now we have 3 lists, and append is pretty good about that. It knows how to take any number of lists and join them together. So if all went well, we should now be able to run our unit tests. And we made a typo. No problem. We always make typos. But we don't make mistakes. Everything worked out great. Perfect. Okay, so we've gotten it so that we can flatten the entire list. Now we'll take this function and we'll modify it so that it flattens only the odd numbers. Specifically, we'll call this find odds. Consumes a binary tree of numbers, reduces all the numbers into a list, but only the odd ones. The ones that look funny. All right, we'll replace our function calls, including the ones in our check expect this time. And we'll add another unit test, this one for something more interesting. We're only producing the lists of odd numbers, so if we produce a list, if we have a tree of just the number 100, we produce the empty list. We will remove the even numbers from our number tree example, and then we'll go back up here and start editing. In this case, we need to do something different depending on if the node's value is odd or not. And that means that in this case, if the node value is odd, we return the element as a list, otherwise we return empty. And I believe that should be all we need. Yes, test passed. I could have done this in several different ways. The if statement could have been on the outside. If the number was odd, then I would have appended the element to the lists. And if it wasn't, I would have only appended the to find odds. I wouldn't have appended the node value. I could have also used a cons to append this value instead of wrapping in a list and appending it. But this style right here ended up being a little bit shorter than both of those options, so I went with it instead.